recall the discussion, or if you're watching the video for the first time, why do we need safety stock? We need safety stock only because there's potentially variability in arrival, meaning arrival of the customer and therefore demand rate. There's a variability in lead time. Lead time is the time between you place an order for replenishment and by the time you receive the order. So if you're in retail business, you ordered something from the wholesaler and the item is coming to you, that's lead time. So there's variability. Sometimes it comes in 2 days, sometimes it comes in 3 days. Demand is also varying every day. And then, of course, there's a desired service level. These are the three factors which cause for you to have safety stock. So what we are going to do is we are going to look at 4 different scenarios. One scenario is when there is no variability in demand and lead time. Other ones are when one is varying, the other is not varying, and when both are varying. So these are the 4 scenarios that we will talk about very quickly. If there's no variability in demand, let's take the simple case. So suppose you have some item sitting with you. You say you have 500 items sitting with you and you're depleting at the rate of 40 per day, exactly 40. There's no fluctuation. My picture is not very good, but let's just assume that this was declining at a constant known rate. And let's say you have lead time is 3 days. So what happens if you're using at the rate of, let's keep a number simple, 50 per day. So this is like 10 days. Suppose you have a lead time of 3 days. That means when you have 150 items sitting with you on your hand, you have enough material to cover the demand for 3 days. So slowly you will deplete, you will place an order at this point. This is your reorder point. And right at this moment, when you deplete all your items on hand, your next shipment will arrive. Remember, there is no variability in demand. Demand is 50 per day. Lead time is exactly 3 per day. And you will really have 100% customer satisfaction. You will have 100% service level. You will not turn away any customer. Of course, this is, this doesn't really happen in real life, that there is no variability in demand, but that's a simple assumption. If there's no variability in demand, safety stock you need is 0, absolutely 0. However, what happens is if you have lead time variability and demand variability, all of a sudden you need to maintain safety stock. So these are the formulas for calculating safety stock, where Z is the desired service level. That affects, because if you have variability in demand is going to be fluctuating. Demand during lead time is going to be fluctuating, and it will fluctuate. It will have slightly different calculations, but the idea is the same. Suppose you want to make sure that you are able to serve customer 95% of the time. Say this number 95% of the time. That means there's a 5% stock out chance. That means 5% of demand you will not be able to fulfill. There's a possibility that may happen, and therefore that is 95 out of 100 chance that you will not run into any stock out situation, but 5% of the chance is you will run into stock out in this example that I have made up. All right. So if your desired service level was 95%, you will have some safety stock. But if your desired level of service was 90%, 99%, obviously your safety stock will be much higher. 99% will go down here. If you were happy with 50% service level, then hey, your safety stock is going to be even smaller. You're happy with 50%. Remember, the area under the curve is 1 if it is normal distribution that we are assuming in all these examples. Okay, so when demand varies but lead time is constant, this is the formula that we will use. Z times standard deviation of D times square root of LT, the lead time, because the demand is fluctuating from day to day to day. If there are 4 days of lead time, for example, then what happens is your variability is going to be, some days it will be more, some days it will be less, and therefore really it will be smaller. It is not going to be, there will be some positive, some negative, they'll cancel out, and that's why this formula is square root of LT. there's a little bit of more explanation, which is basically your, if you think about it, if lead time is 4 days, then variability on day 1, day 2, day 3, day 4 is going to be really plus the second day. And you can add the variances, not the standard deviation. Variances are addable. So when you do that, you'll get 4 sigma square, where 4 is the lead time, okay, if lead time was 4 days. If you take the square root to figure out sigma, standard deviation, that will be square root of, sigma will come out and square root of 4, which is square root of LT, the same thing. That's why the formula is this way. Okay, very simple, very quick explanation. I don't want to get into too much of detail here. If demand rate is constant, but lead time is varying, lead time has a standard deviation, then this is the formula. Z times, Z is again, it relates to your service level. D is the average demand, and standard deviation of LT. If both of them are varying, if demand is also varying and lead time is varying, then really what we are doing here is we are really taking this number and this number, squaring them up and adding them and taking the square root of the sum. So really, this is the formula. Sigma of demand variation, standard deviation of demand variation, times square of that times LT, or variance of demand times LT plus D squared times variance of lead time. So that's the formula we will use for determining the safety stock. And remember, the reorder point is always in all the scenarios, including the first one that we discussed on previous slide, where there's no variability and and therefore no safety stock. Again, the formula is the same: demand during lead time plus the safety stock. And demand during lead time is simply calculated by D times L. And I'm sorry, this should be really lower D. This autocorrect, they made it into capital D. D times lead time, or again, I can write it down, D times lead time plus safety stock. That's the formula. That's the reorder point. And that's true for all the scenarios. Reorder point is demand during lead time. That's the expected demand during lead time. If lead time is 4 days, demand per day is 30. 30 times 4 is 120. That's the expected demand during lead time, plus the safety stock, the extra inventory you have to carry for meeting the fluctuations and, to meet your desired service level. All right. So we are going to, look at 4 different scenarios, and we'll do 4 examples. So example, assume that Eberly College of Business uses 400 dry erase markers per week. The lead time to get the marker from the central store is 3 days. Determine safety stock and reorder point under the following scenario. The first scenario is demand is lead time 400, lead time is 3, and there's no fluctuation. Well, in that case, safety stock is 0, and reorder point is going to be basically the demand during lead time, which is 400 per week. If the lead time is 3 weeks, sorry, I goofed up. It should really say 3 weeks. Let's keep it simple, not make it too complex. 3 weeks, then it is going to be simply 1200. Okay. All right. Second scenario is, again, the demand is 400 per week, but this time there's fluctuation. The weekly demand fluctuation, the standard deviation is 9. Lead time doesn't fluctuate, is 3. And risk of outage is no more than 5%. And other 2 scenarios are described in the similar fashion. There's no lead time here. No variation in demand, but lead time is fluctuating, and here everything is fluctuating. Without doing any calculation, can you tell me which of these 4 scenarios will have the highest safety stock? Think about it. All right, I'll give you the answer. This one should have the highest safety stock, only because you have both lead time is fluctuating and the demand is fluctuating. Among these two, we cannot tell easily which one is bigger because, we don't know what is what is the impact of lead time variability and demand variability. We'll have to do calculation to figure that out. Okay, some calculation to figure that out. There may be some shortcuts, but you still need to do calculation. All right, so let's do these calculations. Let's do the calculation for the second scenario. So again, there's no safety stock. Reorder point is simple, 1200. Okay, and these are weeks. Okay, safety stock in this scenario will be the formula at this time is basically you need Z times you need sigma or standard deviation of D times square root of LT. LT is 3 days. All right, square root of LT. That will be the formula when you have demand is fluctuating, but lead time is constant. And Z is going to be calculated based on, you want 5% risk of outage. That means your service level has to be at least 95% so that you don't have more than 5% of, no more than 5% of risk of outage. So how do you figure out this Z? Standard normal distribution table. So here is the Z table. You have to figure out 95%. Look at this table. It's giving you only from, remember the area under the curve is 1, is 0.5 on both sides, is symmetrical, all that stuff. So if you're looking for 0.95 area, which means if this area, the whole area is 95, and then this area, which is not given in this diagram, to subtract 0.5, that would be 0.45. So that you're looking for the value 0.45 in this table, and read the corresponding Z value off. For this Z value, normal distribution, the area under the curve is 95%. So if you're looking for 0.45, and I see 45 is 45. Somewhere in between these two numbers. This is 495. So it is going to be 1.645. 1.645. I'm just going to take the average of these two because this is as you can see from this curve, this here is 0.4495, 0.4505. I'm looking for 0.45. So between 0.04 and 0.05. So I take this number, but you can take approximately some number, 1.64 or 1.65. So the Z value in this example is going to be 1.645. Standard deviation, you already know, which is 9. And standard deviation of demand. And the lead time is 3 days, 3 weeks. If you do this calculation, you will get the safety stock. And let me just do this calculation quickly on Excel. So I'm just plugging in those numbers here, which is 1.645 times, 9. Standard deviation of demand was 9 times square root of 3. And if you do this calculation, you get 25.6. We always round it up. 25.64. So 26. 26. Safety stock is 26 here. 26. So we know the answer for this one is 26. Now, let's do the calculation for this one. And I'm going to erase the formula here. We did the calculation. Let's do this one here. And the formula here is safety stock deviation of LT. So Z, by the way, this was 5%. This number is also 95%. So, it's going to be exactly the same number that we showed you on the Z table, which, by the way, you can also calculate the Z value using Excel. I'll show you this in a second. Let me just, times D. D is 400. times square root of LT, which is square root of 1. What is the number? 1.64. I just did the calculation on in Excel. That number is 658. 658. Oh, this is humongous number. And that's because if you think about it, why it is such a big number and such a small number here is because look at this one. The variation is 400 and the standard deviation is such a small number, 9 as compared to 400. Look at what's going on here. Lead time is 3 days, but standard deviation is so high as compared to 3 to 1 versus 900 to 4. So I'm not surprised that this number is, is such a huge number. Okay, so that's the safety, the safety stock for second scenario, 658. I'm going to write it down here. 26 I wrote down here. Let's do the calculation for the last one, okay? And the formula for safety stock here is, let me erase, make space so I can write, is going to be Z times square root of sigma D square times LT plus D square times sigma LT square D square. Let me just confirm the formula, sigma LT square, and this is LT times D, correct, square. Okay, that's on next page, correct here. All right, so let's go ahead and plug in. And again, this is 95%. So we know that this number is 1.645 times, you can plug in all the numbers. Demand variation is 9 square times LT lead time is 3 days plus demand square is 400 square times sigma LT square, sigma of LT. So 1 square is going to be 1. So let's go ahead and 645, right? 1.645 times 81 times 3 is 243 plus 400 square. Can I write all the zeros here? 1, 6, 1, 2, 3, 4. Oh, run away. Why are you doing that? Okay, because I'm running to the edge. So let me write smaller. 1, 6, 1, 2, 3, 4. And if you do this calculation, you go ahead and let me just do it on Excel. $1.645, 645 star square root of, and I've done part of the calculation to keep things easier, to 160 zeros, or what is the first number? Well, I'll put it in 243 plus 161234, and you will get 658 or 659. 659. So this safety stock here is 659. And I told you that this is going to be the largest, although it's not significantly larger. It's mainly because, this one doesn't have a whole lot of impact. This one, because the standard deviation is very tiny. This one is a humongous standard deviation, and that is making a big impact. And therefore, this one has a tiny impact. This one has a big impact. And we see that this has 659. So reorder point for any of the 4 scenario is going to be simply demand during lead time plus safety stock. Your reorder point, at what point you should place an order. When the inventory depletes below a certain level, you place an order. So demand during lead time is going to be there are 400 demand per week on an average. Lead time happens to be 3 weeks. And depending on the scenario you have, you can use the safety stock for that calculation. Now I'm going to just show you one little thing, and that will complete the video. How to figure out the, maybe I should do one more example, a slightly different kind of example I should do. Okay, so if suppose you want to find out Z value, right? So suppose the area that you were looking for is 95%, all right? So Z value for this one is going to be normal standard distribution. So select that normal distribution and then say, okay, I'm sorry, that's a probability. I have to do the inverse. Normal standard deviation, and you want inverse because you're looking for Z value, not probability. Probability is given, you are looking for Z value. So 95%, what is the Z value for that? So select that and say probability is 0.95. And if you do the calculation, that will be 0.6448. And remember, we use 1.645. I hope you can see this number. This is what we calculated using this one, or we use a table, and I showed you how to use a table to figure that number out. Okay, let's see if I can find one good problem, and that will complete our discussion on this topic. Let me just do one more. All right, so I found one problem from your textbook, which is interesting. It says it's a problem number 23 from your textbook. It says the demand for circuit boards per day is 85 units. The company has a current policy that when the quantity on hand, the circuit boards that they are using per day for their production, if it goes below 625, as soon as it hits 625, they place a replenishment order. Okay, they have not told us any other detail because it's not really necessary. Lead time is 6 days, and the variation, the standard deviation of lead time is 1.1 day. And they want to know what is the probability of stock out, meaning they place an order, whatever quantity they had, they were depleting it, using it, and it goes below 625. And then, they placed an order is going to be coming in, but there is a variability in the order. So what is the likelihood that the item doesn't come and they already use up all the quantity on hand and there's a stock out? That means they have run out of all 65 items before the order arrives. That's what they want to know. Okay, so we know that reorder point is equal to demand during lead time. Remember that, demand during lead time plus whatever is the safety stock. That's the formula. Okay, 625 is equal to demand during lead time, and the demand during lead time is going to be, you have 65, where's the demand? Demand is 85 units. And we know that demand during lead time on an average is going to be, the lead time is 6 days plus the safety stock. So if you do this calculation, you will get 625 is equal to 8 times 6 is 40, and this is 510, I believe. 48 plus the safety stock. This is a scenario where your lead time is varying, but the demand is not varying. Demand is constant. Therefore, you would be applying the formula for safety stock. Can I subtract 510 from both sides? So when you subtract 510 from both sides, it will become 115 is equal to safety stock. And the safety stock in this scenario, when your demand is not fluctuating, but the lead time is simply Z times D times standard deviation of lead time. Okay, so you know what 115 is. You don't know what Z is because eventually you have to figure out Z and therefore corresponding probability. And times D Demand is 620 is 85. Sorry, demand is where is demand is 85. So demand is 85 once again. 85 here. Okay, so 85 times standard deviation of lead time is 1.11. And again, you can do, you can set this up. Basically, Z is going to be 115 divided by 85 times 1.1, and 1.1 meaning 85 plus 8.5, I know, so it's 115 divided by 85 times, what is it, 93.5. Now, I cannot do this calculation on my own, so we'll have to just see if I can do it on Excel. 115 over 115 divided by 93.5. And that number is 1.2299 or 1.23, okay? 1.2299, all right. So this number is 1.23. All right. So in this case, what they have done is they have given you you calculated the Z value. You know, Z value is 1.123. Remember, the mean of the normal table is 0. So you need to figure out what is this probability. So this is really simple. You have to just go back in the Z table and read up 1.23, and that will give you the answer. So we go up there and read 1.2 and 3 is 39.07. So that number is 39.07. But don't forget to add 0.5. Remember, you are looking for probability of all these things. Sometimes it could be less, sometimes it could be more. But you're looking for 95% of the chance that it will not, 89% of the chance, 39 plus 0.5, so 0.889. So where were we doing? Yes. So probability, corresponding probability for this 1.23Z is 89%. So the 89% chance, the service level is 89%. That means, and again, roughly, I'm not keeping all the percentages, decimals is 39.07, 39.07. So roughly 11% is the likelihood. This implies 11% of probability of running out. Isn't that what they want? They wanted to know what is the probability of running out of stock.